everybody, Dr. Blanchard here. I'm coming at you from campus today. I'm here to do some filming for the upcoming lab. Whereas I could kind of handle doing the other two labs from my kitchen, this one not so much. So I'm going to be doing a little bit of filming in Cushing. And anyhow, I thought maybe you'd like to see how campus is looking. Trying to find some fish in the pond here. I don't know if you can see, there's definitely one right there in the middle of my field of vision, but I don't have very good visibility. We always have questions about how the fish are doing. Students are always pretty concerned about them, especially in the winter. But they're good. I'm sure they're okay. But I think if I had better visibility, we could see a little more. But anyways, campus looks beautiful, as you can see. Looks just like it normally does. It's a little weird to be able to show up though and get parking. There's my car, the only car in Mendel. When has that ever happened? And as you can see on this end, the hyacinths are in bloom. That's one of my, or probably my favorite flower ever. I just absolutely love the smell. And I always look forward to when those bloom on campus. And here's the SAC and our new nursing center. And the other thing I really look forward to are when these cherry trees, I think they're cherry, come into bloom here. So I'm gonna have to find a excuse to come back to campus when those are in bloom so that I can see them, because they're absolutely gorgeous. Well, here we are. Welcome back to Cushing, everybody. Bet you never thought that you'd be missing the chemistry lab quite so much. Let's go in and check out this experiment. So I know I've already explained the general concept of a titration, but just again, what we're going to be doing is we have our analyte. This is our vinegar. The vinegar is the thing that we don't know the concentration of. We don't know the concentration of acetic acid. We want to figure it out. So we're going to figure it out using a titrant, something that we know the concentration of exactly. In this case, it's sodium hydroxide. I'm telling you it's about 0.1 molar. You'll be able to calculate that exactly in the calculation section. So we're using 0.1 molar sodium hydroxide. So I've already filled the burette with our titrant, with our sodium hydroxide. In each of our 3 trials, our 3 Erlenmeyer flasks, I used a 2 ml volumetric pipette. With your pipette bulb, I bet you're thrilled to not have to do this, but I used the 2 ml volumetric pipette to put exactly 2 mLs, 2.00 mLs of vinegar in each of the 3 flasks. And then you'll notice this is slightly more than 2 mLs. You have to add some water just so you have something to mix, just a little bit of volume in there. So I added about 25 mils of water. The amount of water does not matter. Again, it's just so that the stir bar, which we have in here, has something to stir. And what I'm going to do now is I'm going to add the phenolphthalein, the thing with way too many consonants, our indicator solution. And I'm going to put in 3 to 5 drops in each flask. And remember, phenolphthalein is colorless in acid solution. It only turns pink in basic solution. So right now, even though I've added the phenolphthalein indicator solution, you can see that all 3 flasks still remain colorless. So now I have my first flask on the stir plate ready to go. I'm ready to perform this titration. But remember, with the titration in a burette, with the burette you have to know the initial volume of the burette and the final volume of the burette in order to figure out exactly how much sodium hydroxide or how much of your titrant you deliver to your analyte, which in this case is our acetic acid in the vinegar. So before I show you the photo, to show you the close-up, this is how we remember, just remember this is how we record volume on a burette. We use a burette card. We try to look on it straight, and you can see the one line, you can see this big line, which is 0.5 mils, and then you're counting backwards. So then you have 0.4, 0.3, 0.2. So what you have is you have this meniscus sitting around the 0.20 line. And remember with the burette, you always read to 2 decimal places, and it's also read going down. So we don't care how much volume is in the burette. This burette right now contains, I don't know, somewhere around 50 mLs. That doesn't matter. We just want to know what the initial volume reading is. So we're around the 0.2 line, so we'll read it as approximately 0.2 mils. And when we look at the photo, we'll talk about reading it exactly. So take a look at this picture to get our initial volume, and what you can see is the bottom of the meniscus is sitting between the 0.2 and the 0.3 line. So we have to read to 2 decimal places, so my approximation of that is that it's around 0.25 milliliters. That is the initial burette volume. That is what you need to record in your data table. And just remember that when I say 0.25, the 5 is where our uncertainty is. We know for sure that the meniscus is lying between the 0.2 and the 0.3 line, but you have to just make your best guess at what the last decimal place is. So it really could be 0.24, it could be 0.27, but you just have to make some kind of judgment, and then you just recognize that you're uncertain about the last decimal place. So my estimate here is 0.25 milliliters. All right, so I have my flask underneath my burette. I'm ready to titrate because we have the initial volume, and I've just put a bit of a white background so that hopefully you can see the color change. So what you do initially is you go pretty fast. So I'm just going to let this titrant run right into the solution, and nothing's really happening yet. So we go fast until we start to see some pink color appearing, and look, now we're starting to see some pink. So now I'm going to start slowing down, and you see the pink appearing and disappearing. And it's disappearing pretty fast, so I'm still dripping at a fairly fast rate, but soon I'm going to slow this down. Okay, it's starting to take longer to disappear, so I'm slowing it down a little bit. Because what we want to do is we want to capture the point in time when that last drop enters and turns our solution a pale pink. So we're just going to be patient. It's really very pretty. It's a very beautiful color. So you can see the pink's taking longer to disappear now. So I'm getting ready to turn this off. There we go. We got that last drop in, and we have that beautiful pale pink color. So what was going on is initially when it was clear in color, we still had excess acid. We still had acetic acid in there. So the sodium hydroxide was dripping in, reacting with the acetic acid. It would neutralize completely, and you still had acetic acid left over. When we just added that last drop of sodium hydroxide, when it went pink, all of a sudden we had basic conditions. So we had added just 1 drop more sodium hydroxide than we had acetic acid to react with it. So this gives us the end point of the reaction, the point where we've completely neutralized all of the acetic acid with the sodium hydroxide. And you can see here that we are fading back to clear, so that will happen. So when you found just the right end point, the pale pink only persists for about a minute, and then it fades back to clear. So this is like the perfect titration. So let's go ahead and take our final volume reading. So you can see our final volume is somewhere just around 17 mils. So again, I'm going to go ahead and take a picture so we can discuss the exact final volume. So the bottom of that meniscus is lying just below that 17 line. It's between the 17.0 and the 17.1 line. So my estimate for the final burette volume is 17.02 milliliters. So go ahead and record that volume, 17.02 milliliters, as the final burette volume in your data table. Now I'm set up for the second titration. So with the second titration, we're starting at an initial volume that's going to be the same as the final volume from the previous experiment. So just record that in your notebook as the initial volume. Whatever you had as the final volume from trial 1 is the initial volume for trial 2, and we'll just go ahead and do this until we get that nice pale pink again. Okay, there's trial 2. You can see we're a little bit brighter than last time, but it was just that last drop that caused it to turn pink, so we're good. So we're going to take a final volume reading. So that meniscus is sitting right around that 34.1 line, so you choose. Decide what that final volume is. Is it 34.09? Is it 34.10? Is it 34.11? It is up to you to record in your data table as the final volume reading for trial 2. And now we're set up for trial 3. So for trial 3, we did have to refill the burette because there wasn't enough titrant in there, not enough sodium hydroxide. So I'm going to take a picture of that and let you read the initial volume. So now read this initial burette volume for trial 3 and record that into your lab notebook. Remember to record to 2 decimal places. And now that you have the initial volume recorded in your data table, I'm just going to perform this titration until we get to that nice pale pink. Okay, so there we are, and we'll take our final volume reading. So the last piece of data that you need to record for this experiment is this final burette volume for trial 3. And just while I was taking that picture, this is already faded back. This is trial 3. It's already faded back to a very pale pink. So I'll just show you what happens if you way overshoot the endpoint. So you get that color, which is, pretty bright, kind of a fuchsia. So that's adding way too much. That's not the color you're looking for. Again, something closer to this is a good color for the end of a titration. So that's it. We're all done with the titration, and I'm going to clean up here, and then I'll meet you back to work on the calculations. The other reason I wanted to come to campus was to get my office chair. I never appreciated a good chair until I had to just spend the last 3 or 4 weeks, or I don't even know how long it's been. It feels like it's been a year, sitting in a dining room chair, like 8 hours a day in Zoom meetings. So anyhow, this is my office. I have a really great office if you haven't ever come to see me. Decorations on the wall, and here's my office, and I'm going to take that chair home, and I think it's going to save my back. So I actually did get permission from the dean to remove my office chair, but I still kind of feel like the police are going to pull up any second and ask me why I'm stealing things from Merrimack campus. So I'm going to load up my car. So that's it. We're done with the experimental portion of this lab. So while I drive home with my office furniture, why don't you go ahead and take a break and come back when you're ready to work on the calculations. It's a little tour of campus as I'm driving off. Hoping the police don't stop me with my chairs.